Alright, let's go ahead and look at some difference of rational expressions with like bases. So when I mean the base, I mean the denominator. So if I circle right here in green, both fractions have the denominator that's the same, so it's 4. So you're going to rewrite the problem using the common denominator. They both have to be the same. So common means same. And then you have to combine the numerators and keep the common denominators and then simplify the remaining expression. So let's go ahead and do that. So to rewrite this, we would say 2 plus 5 divided by 4. And so you would get 7 over 4. And that's already simplified. It's okay if it's in a improper fraction or mixed number. I'm not really concerned with that. So let's go ahead and look at number 1. I have 13a divided by 4b minus 5a divided by 4b. As you notice, the denominators are the same. And then I have a negative in front of the second expression, so it's multiplying by a negative 1. So if I rewrite this, I'm going to have 13a over 4b minus 5a over 4b. So if I combine over one denominator, I'm going to say 4b, 13a minus 5a. My solution is going to be 8a over 4b, and that simplifies to 2a over b. For number 2, we want to go ahead and look for the same denominator. So in this case, again, it's the same one. And again, we have a negative. So that means the negative will be distributed into the rational expression. So you're going to distribute the negative. So that means it's going to change the sign of whatever's in here. So I have 10x plus 12 minus 7x plus 2. Remember, we changed the signs. Change that sign, we change that sign. All of this is going to be over 15. And then I'm going to collect like terms. 10x and negative 7x. I get 3x. And then my real numbers go together. And it plus 14 over 15. As we were doing before, we want to go ahead and simplify as much as possible. So I'm going to get 3x over 15 plus 14 over 15 equals x over 5 plus 14 over 15. Okay, it's number 2. Okay, working our way down to number 3. Again, I have the same denominator, so that's good. So that means that I'm going to have t squared plus 8t plus 2t plus 21, because it's a plus sign, so all the signs stay the same in the numerator, and then the denominator is the same. I'm going to simplify t squared plus 10t plus 21 divided by t squared minus 9. And then here I'm going to simplify, or I'm going to factor. I'm going to factor the numerator and the denominator. So I'm going to get t plus 3, t plus 7. This right here again is called the difference of squares. And when we factor, we get the conjugate, so it's t plus 3, because I don't have anything in the center, t minus 3. I'm going to go ahead and simplify. So I have the binomial t plus 3 over, or multiplied by t plus 7 divided by t plus 3, t minus 3. So these two binomials cancel out. And my solution is t plus 7 divided by t minus 3. As for number 4, we're going to put these in parentheses. And remember that's a negative 1. It's right there. So it's going to be distributed. And we're only going to distribute into the numerator. So that's a question I often hear. We have the same denominator, so let's go ahead and bring everything together. 1 minus 16x squared divided by 12x minus 3. Now we're going to factor the numerator and the denominator. So the first thing I'm going to do is rewrite it. So I get negative 16x squared plus 1. And then that's all I can do for that. Let's look at the denominator. I'm going to take out a 3. And we have 4x minus 1. Now in this numerator, I'm going to factor out that negative 1. So I'm left with negative 1 times 16x squared minus 1. All of that over 3 times 4x minus 1. Keep on factoring, negative 1. And then I have a 4x plus 1, 4x minus 1, all over 3 times 4x minus 1. These binomials are the same. So my solution is negative 4x plus 1 divided by 3. Alright, let's go ahead and look at number 5. Let's put the first rational expression in parentheses, and then let's remember that we're going to take that negative and we're going to distribute only to the numerator. So we're distributing negative only to the numerator. We want to make sure that our bases or denominators are the same, and they are. Let's go ahead and write this out. X squared plus x minus 6, and our numerator, x squared plus 3x minus 7 minus x minus 1. So I get x squared plus 2x minus 8 divided by x squared plus x minus 6 to factor the denominator. That's why it's so important for us to factor. or to be able to factor. So for the first part, it's x plus 4, x minus 2, and then I have x plus 3, x minus 2. These two reduce and cancel out, so I'm left with x plus 4, x plus 3. And that's it. Sorry, I guess that didn't get shown. But that's the rest of the steps. There's the whole problem. Thank you.